functions are not always given to us in the form y equals a times x minus h squared plus k, which is known as the vertex form. So we need to complete the square sometimes. So please read through these steps, and I'm about to show you how to do this as we turn the page. Let's look at this first function. I need to write this with a blank where the 7 is, so I'm going to rewrite this as y equals x squared plus 8x, leave a blank, and shift that 7 over to the right. Now there are no numbers in front of the x squared for us to factor out, so we move on to the next step, which has us cutting the 8 in half and writing it on the line below. We then square that value to 16 and add it into the blank. Now, we've added 16 to the right side of the equation. From what we know about equations, we should add 16 to the left-hand side, but we don't want to change the y equals that we have there. So instead of adding 16 to both sides, we're going to add it to the right and then subtract it back off and write minus 16 over there on the right. Now we insert the x, the parentheses, the quantity squared, and write that as a completed square. And notice that x plus 4 times x plus 4 is equal to x squared plus 8x plus 16. And then we combine these values together over at the right to have a minus 9. So this is in the form we desire it in, and we're able to identify the vertex to be at -4, -9. Notice I have changed the sign of the 4 as it came out of the parentheses, but kept the sign of the 9 to be negative. To identify the x-intercepts, we want to set y equal to 0. Now we can do this either in the original form we were given, which was y equals x squared plus 8x plus 7, or we could substitute it into the completed square form. It's much easier doing it this way here because the expression on the right is factorable. We can write this as x plus 7 times x plus 1, and we can see that x is equal to -7 or x is equal to -1. And that tells us that the x-intercepts are located at -7, 0 and at -1, 0. To identify the y-intercepts, now we will set x equal to 0. Again, I'm going to go to the original function, y equals x squared plus 8x plus 7, and you can see that when we substitute 0 in for x, we're going to just have the 7 over here on the right. And it turns out that whenever you have the equation in the form ax squared plus bx plus c, that the value c will be your y-intercept. We will have a y-intercept at 0, 7. So let's now sketch this graph. We've said we're going to have the y-intercept at 0, 7 units above the origin. We've also said that the vertex will be at -4, -9, and we've said that the x-intercepts will be at -1, 0 and -7, 0. We can probably guess we're going to have another point up here by symmetry. I'm going to try and draw it right there. Close enough. And we have the curve. Make sure it has a smooth curve at the bottom. It's not pointed when you go and draw it. Now, the vertex here again was located at -4, -9. To identify the axis of symmetry, that will be at x equals, which is what we have when we have a vertical line, and it will be at x equals -4. This function will have a minimum value because its graph opened upward, and therefore let's not write y equals, it sounds like an equation or line. Let's just write down that the minimum value is going to be at -9. That value will always be y equals k. Whatever the h comma k is for the vertex, the y coordinate of the vertex will be your max or minimum value. The graph of our function extends forever left and right, so the domain is all real numbers from -infinity to +infinity, and the range will start at -9 and extend upward to +infinity.